Hi everyone, I'm from Group 3. Today I will talk about the single seeds descent, SSD for short. SSD is a plant breeding method that involves selecting one seed from each segregating plant to advance to the next generation, aiming to rapidly develop homozygous lines. Originally proposed by Golden in 1939 and later modified by Brim in 1966, SSD minimizes record keeping and is particularly effective for improving quantitative traits such as yield. This technique allows breeders to maintain genetic variation while effectively progressing through generation, making it sustainable for self-pollinated crops like wheat and barley. By focusing on individual seeds, SSD enhance the speed of cultivar development compared to the traditional breeding methods.
Okay, now I want to tell about significance. The method facilitates the perfection of genetic traits and is particularly valued in self-pollination crops. Its simplicity and efficiency make it a perfect approach for creating genetically uniform populations that are essential for research, breeding, and the development of new crops varieties. The single-set descent method immediately comes as the most effective approach for swift development of genetically stable and homozygous plant life. By advancing single set from successive generations, single set descent reduces natural selections and sampling bias while rendering the genetic diversity of the original population intact.
So, I would like to talk about the application of single seed descent SSD. Firstly is development of new crop variety. This is used to create genetically uniform crops such as wheat, barley, and soybeans with traits like high yield or disease resistance. Other than that is conservation of genetic variation. It allows breeding without losing the genetic diversity of the original population. Further is genetic trait evaluation. This is help identify important genetic traits such as disease resistance or tolerance to stress factor like drought or salinity. Furthermore is reduction of time in research costs. This accelerates the development of crop varieties by reducing the number of generations required with minimal space and type needs. Lastly is research of genetic population. This assists scientists in study genetic variation in plant population, improve understanding of specific ergonomic traits. Furthermore, I would like to talk about benefit of single seed descent. First is space efficiency. This method requires less space for breeding population. Other than that is time efficiency. It decreases the time to develop a new cultivar by rapid advancement of generation. Further is minimum record keeping. Management is relatively simple as compared to other methods and only bulk seed lots need to be selected. Lastly is increased genetic evaluation. It allows for evaluation of genetic variability and thus trait with low heritability. That's all for me. Thank you.
The single seed descent method is an excellent tool for rapidly advancing through generations, allowing plant breeders to achieve desirable traits in a fraction of the time compared to traditional methods. So now let's take a look at how this method plays out throughout the years. Our journey begins in year 1 with hybridization. In this step, we cross two parent wheat lines that exhibit desirable traits such as high yield potential and resistance to diseases like rust or blight. From this cross, we produce approximately 100 F1 seeds, which are the first generation of offsprings from the parental plants. After the crossing is done, we grow the F1 generation in a controlled environment to ensure that they grow and thrive properly and to prepare them for the next stage of the process. In year 2, we harvest the seeds from the F1 plants to grow the F2 population. This generation consists of around 1,000 plants, and here's where the SSD technique really takes its course, because we apply the single seed selection, meaning that we only pick one seed per F1 plant for the next generation. As we move into years 3 through 5, we continue growing the selected seeds from F2, F3, F4 and F5 generations. The number of plants per generation decreases as we advance, with approximately 500 F3 plants, 250 F4 plants and 125 F5 plants. During these years, we also conduct preliminary yield and disease resistance trials to evaluate the performance of the plants of each generation. In year 6, it's time for our final selection. We choose the top performing lines from our preliminary trials, narrowing it down to about 20 to 30 superior lines. These lines will undergo large-scale yield trials in multiple locations. Finally, in years 7 and 8, we focus on seed multiplication. We take our top lines and produce thousands of the seeds for commercial release. This is where our hard work pays off as we prepare to release the new variety to farmers. And that's a quick overview of how we develop a high-yielding, disease-resistant wheat variety using the single seed descent method.
Berdasarkan diagram ini, langkah pertama dalam kaedah pembiakan keturunan benih tunggal ialah kacukan. Jadi pada tahun pertama, kita kacukan 2 variety tanaman yang berbeza. Contohnya jagung daripada induk jantan dan daripada induk betina. Untuk proses dia, kita pilih dulu biji benih yang paling terbaik daripada induk jantan dan induk betina dengan 2 variety yang berbeza dan ciri-ciri yang kita nak. Bila kita dah pilih, kita tanam dia dalam susunan barisan. Jadi 4 baris kita tanam induk betina, 1 baris kita tanam induk jantan. Jadi nisbah kita 4 nisbah 1. Okey, bila dia dah besar sikit, untuk induk betina, kita buang dia punya tassel. Kan kalau jagung dia ada dua bunga, jantan dan betina. Tassel tu ibarat bunga jantan sebab dia ada pollen. And then silk and ear tu female part dekat bunga jagung tu lah. Jadi kita akan buang tassel iaitu bunga jantan pada satu pokok jagung tu lah. And then kita jadikan dia sebagai induk betina sebab kita buang bahagian male part dia supaya dia tak berlaku self pollination lah dalam pokok yang sama. Lepas tu untuk induk jantan pula tak buang dia punya tassel. Jadi pollen daripada tassel dia tu dia akan terbang, dia akan jatuh atas silk daripada induk betina. Dan bila dia dah berbuah, kita harvest dia punya biji benih iaitu F1 dan kita keringkan untuk penanaman seterusnya. Untuk langkah kedua, bila masuk je tahun kedua, kita tanam biji F1 yang kita harvest tadi tu sampai dia berbuah. Jadi hasil yang kita dapat tu jadi F2. And then kita pilih 1 biji je daripada setiap pokok yang kita tanam tadi. And then kita keringkan biji dia and kita simpan untuk penanaman seterusnya. Masuk je tahun ketiga, kita tanam biji F2 yang kita dah keringkan tadi. And then kita tanam untuk kita harvest, kita dapat biji daripada F3, F4 and F5. Tujuan dia untuk kita test ciri-ciri yang kita nak tu dia dah ada ke belum dekat biji yang kita tanam tadi tu. Bila masuk je tahun ke-6, kita pilih biji yang terbaik daripada F3, F4 and F5 tadi dalam anggaran 20 hingga 30 biji. Lepas tu kita tanam dalam skala yang lebih besar dan lokasi yang pelbagai. Dia masuk je tahun ke-7 dan ke atas, hasil daripada biji yang kita tanam di pelbagai lokasi tadi tu kita harvest and kita biarkan dia lagi. And then barulah kita boleh jual kepada para petani.
In conclusion, the process is simple and highly effective, and its relevance for the breeding of cereals such as wheat, barley, and soybeans, and case studies for developing high-yielding and disease-resistant wheat varieties are somewhat illustrative in terms of the approach or organization that evolved from hybridization to mass multiplication of seeds. SSDS provide ways to accelerate the process of instrumental reproduction while ensuring uniformity and stability in seeds that have helped deliver a wide range of new crop varieties to farmers to develop sustainable farming strategies. That's all from me. Thank you.